Hello, Mr. Stoller here. So today we are going to look into Geomorphology 2, okay? And Geomorphology 2, we're going to cover drainage patterns, drainage density, stream order, and river discharge. Okay, so let's get to see what we have today. So first thing, we need to understand some terms, like important terms here. The pattern is arrangement of streams in a drainage basin. Then resistant to erosion, hard rock that do not erode easily. So erosion is the washing away of what you call of a bit soil, also even the ground. Okay, so that's what we're talking about. It can be caused by water, and it can be caused by what wind, which you call wind erosion and water erosion. But in this case, we'll be focusing on the water erosion. Okay, then underlying rock structures, type of rocks on which the river stream flow. So this also affect what called the pattern in the in the drainage basin. So this is important. This is very much important here. You need to understand the underlying rock of the streams. So each stream pattern will be having a different underlying rocks. Now let's look at alternate layer of hard and soft rock next to one another. So you see that in other streams, another stream patterns, you will see that there is alternate hard and soft rocks, what called in the area. Now, let's start to look on the different patterns, what we call drainage patterns that we're going to look at today. So there are 7 of them. So we're going to start with dendritic pattern. So dendritic pattern, you can see how the streams join. So the streams join at an acute angle. So we are saying the angle they join with, you can see that it's small angle here. That's what we are saying here. They join at an acute angle, meaning to say they join at a small angle than 90. Then they resemble the branches of a tree. So you can see when you see a tree-like pattern, you know that that's a dendritic pattern. Where do we find this type of dendritic pattern? We found in areas with rocks of equal resistance, what called to erosion. So what type of these rocks? We are saying they are uniform rocks. Okay. So uniform rock areas. So you're saying they are uniform, what called rock structures. Okay. That's what we have. Okay, then so you can see the example here. In reality, you can see what we have here is a picture here that actually shows you how the tributaries are connected. You can see that the tributaries, when they are joining, they join at a small angle. Let's move on to the next one, which is the trellis pattern. So now we can now see what is happening with the tributaries. Our tributaries are joining at 90 degrees. So here it's what called right angles. So right angles, it means that what called is they are joining at 90 what called degrees. That's what we're talking about here. So when we're talking of right angle, they are joining at 90 degrees. So the main streams are parallel to each other. So you can have what called in a trellis pattern, you find that the streams, even you can see the tributaries, how they are parallel what called to each other, because they are all joining here at what you call at 90. Where do we find these streams? You can see that streams pick out bands of weaker rocks and erode along them. So here what happens is that as the streams are what call with the time, they try to find a way to, like water, try to find what called the weakest point where it can crack and move and use that as their what called their route to the sea. So what happens now is that whenever they find a weak point, a crack in the rocks, they use that. With time now, with erosion, the stream get bigger. That's why we have this what call the tributaries are developing and joining at 90, because when we have a creek, you don't have a creek that goes like this in what you call in rocks. You have especially what you call sedimentary rocks. You have a creek that is actually straight. So here, that's why we are saying the streams join the mainstream at 90. Now, here you can see that we have, it's okay in areas where hard rocks and soft rocks are what called alternate. So sometimes it's not a crack, but it's a what called, it's a part of, what is it? Part of the rocks are weak. So we've got hard rock, then weak rock. So we've got maybe let's say here it's an hard rock here. The stream cannot do anything here. Then we have, you can see that it can't continue to go there. Then here, part of there is actually a soft, what call a rock, where the stream can actually find its way to the mainstream. Now, let's look at this, the third one, which is the radial pattern. The radial pattern, you can see. Now, I don't want you to confuse radial pattern and what call, and what is this one here? A centripetal pattern. Okay, I just skipped it, but I don't want you to confuse. Can you see what is happening in the centripetal? All the streams are coming, coming together. So they're emptying in one, they're moving. We can just say they're moving to the one lake or one dam, all of them. But here, what we have with the radial pattern, we have our streams moving away from each other. You can see that they are coming from a central point here. The central point can be a hill or can be a mountain. So this can, you can see that it's a hill or it can be a mountain. Now, on a mountain, you find that on each side of each mountain, there are streams developing there, and they go what call opposite sides. So especially if the hill is steep or the mountain is steep, you find that you have got more streams forming on all sides. And you can see with the direction, they are going in opposite direction. They are going in opposite. They are moving away from a central point. So that's what we have there. Okay. So streams radiate from a central point and found in areas with the dome-like structures. So this found, you can see that a volcano occurred before, and you can have what call a hill structure here that is what call giving rise to a radial pattern. Now let's move on to the next one, which is a rectangular pattern. The mainstreams displays right angle bends. So what happens to the mainstream? The mainstream here, it actually follows cracks in the rocks. So you can see that it make what call 90 degrees bends. Okay, 90 degrees bends. We are not saying the tributaries, they are joining at 90, but we are saying here the mainstream itself is moving like this with bends. That's the mainstream here. Okay, that's the mainstream. So the mainstream, it displays what call right angle bends, which is the 90 degrees that we once talk about. Okay, it found in areas with igneous rocks. So here you must understand that these are igneous rocks with the joints and the crack. So this is an example of what you'll actually be seeing. You can see that the mainstream, how it's bending here, and it's also bending here, and it's bending. That's what we're talking about there. Now let's look at the derived pattern. Where do we find this? You find this in not here in what call in Africa. You find that where the region subjected with the glaciers, which is what call ice, mass of ice. Okay, mass of what call ice. So here, when that ice melt, you find that you can see what we're having here. We have got small lakes. So the streams, the tributaries actually will empty in a lake. We have got the mainstream here, but then we have got small lakes around. So it doesn't have a clear what call pattern that what call tributaries follow or the mainstream follow. Okay, so streams have irregular patterns. Okay, the tributaries do not link up with the mainstream. So you find that you can see what we have here. We have a tributary here, empty in a lake. We have another tributary here, empty in a lake. Then from that lake again, you have another stream formed, then empty again in a lake. That's what is happening here. And we are saying it occurs in the regions subjected to what you call glaciers. Okay. So this is just a mass of ice that is moving slowly, what you call maybe down the mountain, and with the time now, it actually melts there and form what we call these what we call small lakes there. Then, but it continues again like that. That's what we are talking about here. Let's move on to the next, what you call the last part of our drainage patterns. So we have what called centripetal pattern. This is more like opposite of a radial pattern, where we are saying here the streams converge. So on the radial pattern, the streams were diverging. So here the streams converge into a low-lying area. So now we're saying river discharge their waters from all directions in a lake or a depression. So this can be a part of maybe a valley between the mountains, where we have got mountains, what called tributaries coming from this mountain here. There's another mountain there. There's another mountain there. Goes on like that. Then here in the middle here, we have got what called more like a lake, which all the rivers are emptying into. Okay. Now, so we are saying it's a basin-like structure. So it's more like it's a basin. So it's a basin-like structure, what you call a pattern. Then let's move on to the last part of the pattern, which is the parallel pattern. Now, parallel pattern here, we have got, it's formed on steep slopes. So patterns of rivers caused by steep slopes with some relief. So because of the steep slopes, the streams are swift and straight and with very few tributaries, and all flows into the same direction. So here we have got few tributaries because it's much steep. When they join here, they don't have much tributaries compared to what you call like dendritic pattern. Okay, so here we are saying the streams are parallel, what called to each other. What type of rocks, what type of surfaces do we find this? We are saying parallel drainage patterns form where there is pronounced slope to the surface. Okay, so there's a pronounced slope to the surface, and we are saying the parallel pattern also develops in the region of parallel elongate landforms, what you call like outcropping resistant rocks. Okay, that's what we have in the trellis pattern. But what is important here, guys, is that you need to understand, you need to be able to identify what is it, the pattern. You need to be able to identify the pattern, and being able to know that why do we have parallel slope, parallel pattern. It's we have it on steep slope. So these are the major things that you must understand. We have it on steep slopes, and here we are saying the rivers are discharged in the what you call from all directions. That's what we see there. So once you see these arrows here coming in, you know that no, that one is centripetal. When you see streams going out, you know that that one is radial. Now, let's move on to the drainage density. Now, drainage density is a measure of length of stream channel per unit area of drainage basin. It describes how many streams they are in a drainage basin. Okay, so it determines how many streams are we having in a drainage basin. So if you've got more streams, it means that high drainage density. Less streams, low drainage density. So, but let's listen here carefully. It's affected by infiltration and runoff. Okay, then we need to know the definition here. Infiltration, the water soaks or filters into the what you call soil. So here we're talking of just sinking of water. So water in the soil. So sinking of water in the soil is what you call infiltration. Now, what about the surface runoff? Is what you call which is what we have here is water moves across the surface of the earth, becoming a stream, tributary, or a river. So when you have got runoff here, we are saying the water is not infiltrating. What is it doing? Is running what call off, and what we're having here is on top of the surface. It's flowing. So we're talking of flowing of water here. That's what we call runoff, flowing of water. Now, here's an example. Here's an indication of which one is low drainage density and which one is high drainage density. So here you can see that we've got high drainage density here and low drainage density this side, sorry. Then you've got high drainage density because of what? More streams per unit area. So we're just talking of, when I talk of drainage density here, drainage density, we're just talking of number of streams, number of what call streams in a drainage basin. drainage basin. So here we are talking of number of streams because we want to know how many streams are we having in a specific drainage basin. Once we have got more streams, it means that like here high drainage density. Then what about less streams? It means that low drainage density. Now let's now understand these two now, where we're talking of infiltration. Then we have got what you call surface runoff. Now, let's have high infiltration. Then we have got low infiltration here, high. Then we have got low. Now, I want you to understand something here. When you're talking of infiltration, when more water is actually sinking, when more water is sinking, it means that we have got less runoff. So here is characterized by less runoff. So when you've got high infiltration, it means that we've got less runoff, less water flows. And when we've got less water flows, are we going to form more streams here? No, less streams formed. So we've got less streams formed. Now, when we form less streams, what call in the what call when we've got high string, do we have now? We have. Does it increase drainage density or less drainage, lower the drainage density? So we've got low drainage density. So here we are saying when you've got high infiltration, it's characterized by low drainage density. It's characterized by low drainage density. That's what you must understand. Why do we have that? Because we've got less runoff, we have got less streams formed, so we don't have much there. But when we are having what you call low infiltration, it means that less water sinks and you have got more runoff or high runoff now in this case, high runoff. So most of the water flows. And when we have got more water flowing, what are we forming here? More streams formed. Now, when more streams formed, what are we doing here? We are increasing drainage density. Increasing drainage density. So these are the explanations that you guys will be asked here. So you will be asked these things here. You will be asked these things here where relating infiltration and what called drainage density. So when you talk of drainage density, the factors that affect infiltration are the same factors that affect drainage density. Now let's look here at runoff. Runoff, when you have got high runoff, what does it mean? We know that when you've got high runoff, it means that less water is infiltrating and we are forming more streams. So here we are actually saying when you've got high runoff, it means that less infiltration. And when we've got less infiltration, we have got more flow here. So more water flows. And what do? We form more streams. And when we form more streams here, what happens? We are increasing drainage density. That's what you're doing here. What about here? When we have got what you call a low runoff, it means that we have got a high infiltration here. And when you've got high infiltration, it means that less streams. Less streams, we are decreasing, so low drainage density. Okay, so what did we master today? high infiltration, low draining density. Low infiltration, high draining density. High runoff, high draining density. So we can say we can just say, if we are to talk of a proportionality here, we are saying drainage density is directly proportional to surface runoff. So when you say directly proportional, it means that increase in drainage density with increase in runoff is going to also increase drainage density. So what about what you call drainage density here and infiltration? Drainage density is inversely proportional, meaning to say 1 over inversely proportional what you call to infiltration. Okay, so this is to talk about this one is inverse proportional and this one is direct proportional. Increase of one will also result in the increase of another. That's what we're talking about there. So we can move on. I hope you guys have mastered this and you will be giving these explanations in your exam. Now let's look at the factors influencing drainage density. Factors influencing drainage density, those are the same factors that they can ask you what call that influence what call infiltration, and also what call runoff, which is the flow. Sorry about that. Okay, which is what call the flow. So here we need to understand that. So these factors we have to talk about precipitation, we talk of evaporation, we talk of porosity, and in Geomorphology 1, I explained this, what called the porosity. I explained these factors here. I did explain them very well. We have got slope here, which is the gradient. So porosity, we can also have just talk of permeability here, but I did explain everything there in the what called Geomorphology 1. Then you also talk of vegetation cover. Then we talk of soil moisture. Now, you need to understand how each of these affect what called drainage density. Because if we've got high rainfall, like for example here, we're talking of a decrease what called in precipitation, such as in arid in arid environments, results in low drainage density. So here, when we have got low precipitation, is associated with less rainfall. So we're talking of precipitation here, we're talking of amount of rainfall here. So that's what we actually, it's not the definition, but that's what we're actually referring to. Amount of what called rainfall. And frequency as well. You understand? So frequency. So when you've got more frequency, and also high rainfall, what do we have? We have got a high drainage density. More streams will form. But if we have got less rainfall, less precipitation, it means that we are not going to form more streams. And when you don't have much streams, we are saying it's a result in the low drainage density. That's what we are referring to here. So we are saying low precipitation, decrease in precipitation, result in low drainage density. So you must be able to explain this, what I'm saying here, you must be able to explain it very well. So you're saying a high evaporation rate will lead to fewer number of streams. So when you've got more more evaporation, loss of water in the air, what happens? We have less streams. Then you've got high porosity or high permeability, okay, will lead to high infiltration and less streams. So here is the thing here. When we have got high infiltration, remember what I just indicated, that what called in the previous slide, we are saying we will result in low drainage density because less streams will form. Then let's talk of slope. So when we have got a steep slope allows formation of more streams. But here, when the slope is gender, what happens? It results in the low drainage basin because less streams will form because of gender slopes. Gender slopes are more like flat, so they are increase filtration. They favor infiltration, not runoff. So we're just saying flat surfaces, they favor infiltration. Then if we've got steep what we call surfaces, they favor runoff. Once we have runoff favored, what happens? High drainage density. So here this has to do with what called, so we can say low drainage density here, we can associate it with what we're talking of high infiltration. Then here we're talking of high, low surface runoff. So low surface runoff, high infiltration result in the low drainage density. Simple like that. Now, areas with the high vegetation cover will have high infiltration and less streams. Now, once we have got high infiltration here, we have less streams. So when you've got more vegetation cover, it results in less streams because more water is being absorbed. So if you listen to lecture 1, the geomorphology 1, I was explaining there, when you've got vegetation cover, we are increasing what you call infiltration. Now let's talk of a soil with little moisture. So if the soil have got little moisture, it means that it's going to allow more infiltration here because it still needs to absorb water. It still needs to absorb what call water, and when it's absorbing water, it's that's infiltration. And what happens? We have less runoff, low drainage density. So I hope you guys have mastered. These are the factors that you must always indicate. You play around. You must understand vegetation cover. What does vegetation cover means? How does it affect my drainage density, sorry. How does it affect? So if you know that, then you are home and dry. Let's continue with the factors here. So now we're just having high drainage density. High drainage density, what happens with high drainage density? We are saying there is low infiltration. Then here we've got high surface runoff. So high surface runoff, it results in the high drainage density. We have indicated that from the start. Now we understand these things. Now increase in precipitation results in high rainfall, high runoff. So if we have got more rainfall, we have got more streams going to be formed there. It was always raining and it's heavily, and now we are saying it's actually more runoff. What called, and when we have got more runoff, what happens? We have more streams formed. So we've got more of erosion taking place there. When we've got more erosion taking place, it means that we are having more streams formed. So here is also here to talk of high erosion. So here it's associated with high erosion or increased erosion. Now, low evaporation, it means also we are forming more streams. We are losing less water. Then low porosity and low permeability. If the surface does not absorb water, what happens? We have got more runoff taking place. Then slope or gradient, steep slopes allows more runoff and less infiltration, because if you are to to put water where it's steep, you find that the water will quickly slide there or will quickly flow. But if we put it in a gentle place, like on a table, flat surface, the water will stay there and try to find if it can sink or not. Now, areas with little vegetation cover, we have little infiltration and high runoff. So guys, I want you to know that when you're talking of drainage density, I'm going to do this again because I don't want mistakes here. Drainage density, we only deal with what? Infiltration and runoff. Surface runoff. That's what we deal with here. That's what you must understand, guys. We don't need to stress here. We don't want stress here. Okay, now let's move on to the the next question, next slide. Now, what are we having? Let's try to attempt something together here. Define the term drainage basin. So here we're having what we call drainage basin here. And what are we having? We're having the streams here and these tributaries, and we want to know what is drainage basin. So it's 7.11. So this is the area drained by river and its tributaries. Okay, then let's move on to 7.12. Identify the drainage basin, drainage pattern, assumed by the river river system in the drainage basin. So what do we have here? We can see that our streams are joining at 90 degrees. Can you see that? They are joining at 90 degrees. Can you see that? That's what we're talking about there. So what is happening here? We are saying the reason there is that it's actually trellis pattern. Then let's move on to 7.13. Give one reason visible for your answer in question number 7.1.2. So we can all see that the tributaries join main stream at right angle. Or even you can say at 90 degrees, there's no problem. We are saying they join the streams, the main stream at right angle. That's what we see. That's why we have said it's trellis. That's the only reason. Now let's move on to 7.14. Drainage density of river system seems to be denser, finer at R than at S. So we are saying here we're more having drainage alcohol density here than alcohol at S. Okay, explain why this is the case. Okay, explain why this is the case. So the reason there is that we are saying this part here is steep. So it's steep. That should be the reason. So here it's steep. Steep slope. And R. Because you can't have a dam on a steep slope, guys. You can't have a dam on a steep slope. You have a dam, what you call it, S date close to the dam where it's emptying, what called the river loses its energy now, and it's emptying into a sea. And this can be a steep, it's gender. Okay, that's why. So here is the reason here. It's more steep here. You can even see with if you check even here, you can see that here at R here, it's more steep. If you look on the side here, because this is a cross section, so you can just look here on the side here, you can check that, you can see that this is actually steep slope. And on a steep slope, we have got high drainage, what called density, remember? Now, determine the stream order of river system where it flows at X. So stream order where it flows at X. What do we know about stream orders now? We have got this here is stream order 1. So when you go I will explain that on the next slide here. Let me just go there and explain to you here what we have. before the stream orders. Okay, we'll come back to the question, don't stress. Stream orders. So here it actually shows that here is a tributary, it's a stream without tributary. So this falls under stream order 1. So stream order 1, the stream does not have a tributary. But once we have got tributaries joined together, we now form what called a stream order 2, meaning to say we've got stream order 1 and stream order 1 joining together. Then here we have got stream order 1 and stream order 1 joining together, then you form stream order 2. Now, when you've got two stream orders, so here you've got a tributary, this one also have a tributary. When they join together, they give us a stream order 3. But you can also see that on a stream order 3 is joined by stream order 1. It doesn't matter, it remains stream order 3. Then here, if you have got a stream order 3 joined by a stream order 2, it doesn't matter, guys, it gives us stream order 3. But now when two stream orders, like stream order 3 and stream order 3 joins, that's the one that will give us stream order 4. So always remember that when you've got stream order 2, stream order 3, and stream order 3 joining together, you have stream order 4. So it means that if you've got stream order 4 and stream order 3 joining together, it's still stream order 4. So we always take the highest stream order there. Then you can see that we have got stream order 1 joining stream order 4. It doesn't matter, it's still stream order 4. Then here we've got stream order 2 joining the stream order 4. It doesn't matter, guys, it's still stream order 4. So it goes on like that. So always remember, when you've got a 2, 1 and a 1 give us 2, 2 and a 2 give us 3, 3 and a 3 give us 4, then 4 and a 4 give us 5. I hope we understand that. So here is the laws of the stream order. The steeper the slope, the lower the stream order. So you've got the steeper the slope, it means that less streams joining. So you've got less tributaries. On a steep slope, we've got less tributaries. Joining. The bigger the drainage basin, the higher the stream order. So if you've got a bigger drainage basin, it means that we've got more rivers. It's a big area. So here it has to do with the area. The area is big. So when the area, is a big area, is talking of more streams also found on a big area. Now, what about the longer the stream, the higher the stream order. So if we've got more the long stream, it means that we are going to have more tributaries. Tributaries joining. So here, if you've got a long stream, it means that there is more high chance here of it being actually joined by many streams. And when it's joined by many streams, that's also give it what we call a higher order. Now, there are more lower orders than higher order streams. So you can see we've got more 1 here, and we've got more small tributaries with no other tributaries, which are your stream order 1. Then here, I just wanted to finish up on this part here, then you can go back to the questions. We don't know, maybe they might ask us this as well. Now, river discharge, we have to talk about the flow, how the water flows, So how water flows is determined by the surface, the riverbed, which is the surface. So the river surface, if the river surface is rocky, so it means that here with the turbulent flow, it means that there is unstable movement of water there. You've got increase, decrease, it increases speed, reduce speed. There's more turbulence there and more disturbance. That's what we're just saying here. And disturbance from what we are saying is a rough surface. And this rough surface consists of rocks. So we've got rocks Okay, and rocks, we've got the rocks here, rocks, and with these rocks here, these are the ones that create some block water, some what we call a steep, some, it goes on like that. So the surface is uneven. Okay, that's what we're talking about when we talk of turbulent, what we call flow. Turbulent flow is water motion characterized by chaotic changes in pressure and velocity. So the speed increases, the speed reduces, the pressure also of the water increases. It depends. It changes along the stream. It changes as you move along the stream. Then why is water flows bubbly and riverbed is uneven and more erosion? That's what you're having. So you can see how the water actually is flowing here. That's what we call a turbulent flow. So you must be able also to notice it. And now, what about laminar flow? Laminar flow is where we're saying this the surface, we have got a smooth surface, guys. Smooth, even. So let me just say smooth surface. That's what called the laminar flow. So laminar flow is water motion created by smooth layers of water, and we are saying here water what called flows in parallel sheets. Riverbed is even less erosion. So you've got more erosion here, and this one also, this one is more silent here. The what called the laminar flow is silent. You don't hear noise. So here it's silent flow. So here, but it's noisy. Now, so that's what we, so I think if you can, if you have got uneven what call surfaces, you can even hear the sound of the flow of water. You can say, tell me, no, there's a river down there. But if we're talking of laminar flow, you just see when you get there that, oh, there's a river there, because it's quiet and actually doesn't not make any noise. So we must be able to tell with this one is laminar flow and why is it like that, and actually how does it behave. So these are the things that you must notice. So this is the last slide there. Let's get back to the question so that we understand each other. So they are asking us here, determine the stream order of the river system where it flows at X. Now here, can we see what we're having here? This is stream order one, and when it's joined there, now we have got stream order 2. Let me just put it like this. Which color can be visible there? Let me see. Stream order 2, and again we're just joining here stream order 2. We still have stream order 2 here. It joins here. Stream order 1 is stream order 2. Then here this one join. This one is stream order 2, and stream order 2 and stream order 2 meets. What do we have? We have a stream order 3. So here the stream order is 3. So we don't need to stress here that we are having a stream order joining here. Remember, it is 2 here because we're having 2 tributaries form joining here. But this is 1, this is 1, this is 1 here, this is also 1 here, this is 1. But when you say 1, 2, 1, 2, 1, 2, doesn't make any difference. Then here it moves on like that. But let's just help each other as well here. We have got stream order 2 also here. And when it goes down here, it meets 2 and 3. What do we remain with? Is still 3. Okay. Then we have got stream order, what do you call 2 here. It's going to be 1 here, 1 here, 1 here, 1 here. And this is 2 now. It's also 2 there after joining another stream. It's also 2. When you say 2 and 3, what do we have? We still have stream order 3. So you can see that here up until it empties into the sea, it's still stream order 3. Now let's move on. So 7.1.6. Now, at which point R or S would there be a greater risk of flooding? Why? Where will we have what called greater risk of flooding? So why and also why? Explain your answer. So will we have a greater risk of flooding at S? You can see what we're having here. This water is still flowing here, and when it's remember these tributaries, they are joining each other, emptying water into the mainstream, and here stream order, we still have more water being emptied. So it means that by the time we reach S here, there is more water in the what? in the stream, and that more water can result what we call in the flood. So A, we understand that it's a, what is it? It's S. Then what about B? Let's look at B here. At B, we are saying explain your answer. Why are we having that? Because more water. More water from tributaries. And gender. So we've got more water from tributaries, and also the slope is gentle. So at S is gentle slope. And when you say gentle slope, it means that it doesn't what could rush more water there, and it means that we're going to have what call flooding around S, not what call on top here, which is R. Now, what do we have here? We've got write a short paragraph or approximately 8 lines outlining flood prevention methods that can be implemented to reduce the risk of flooding in the drainage basin. So how do we reduce flood? So we're going to plant vegetation on the banks. So we need more vegetation, and when we've got more vegetation, it means that more infiltration, and that water is going to be absorbed. Okay, then what we can build, we can also divert water. The river. So they're diverting the flow. Diverting the flow. So we can divert, let's say for here, we can divert here. And actually, when we divert the water flow, it means that we are reducing amount of water that will be actually available at 3. Then here we can also build artificial leaves. So here, build artificial leaves. Now, these leaves are just barriers. So you block, that blocks the water. So we can build barriers or walls. Walls or to block water. So we can channel the water. So when you build the walls, we actually trying to channel it towards S there. We can build some walls that avoid water from getting into maybe where people stays, because remember the flooding part here, it has to affect us humans and the ecosystem. So we try to divert the water or build by building artificial leaves that will block the water in the system. Then what can we also do? We can also let's see here. We can also build dams. Dams are what called to hold water upstream. Because if we were to build a dam, let's say we build a dam around just after X there, it means that we're not going to have more water escaping to the sea. So we hold water this side here. And when we hold more water this side, it can, when you've got heavy rainfall, that's when it can spill on the dam. But now when it spill, it won't cause much harm. What we're just trying to do here is to reduce water on at S, so that we also be reducing what we call flooding. Okay, that's what we're talking about there. Then let's move on to a next question there. Refer to Fig 8.1, which shows drainage basins, okay? Explain the term drainage density. So here, 8.1, we have drainage density. Remember what we said? This is number of streams per unit per area. Number of streams in a drainage basin. So this is your what call your what is it, your drainage density. Let's look at number 2 there. What do we have? Compare the drainage what we call density at A and at B. So here we are saying at A we've got high drainage density. So at A, more streams. Okay. High drainage density. Okay. So we've got high drainage density there. So, and at B, we are saying there's less streams, low drainage density. Okay, so why am I explaining this? I'm explaining here so that you understand what is the meaning here. When you're saying high drainage density, what is it? But here, this is important here to not to write down here. You don't have to miss this because we are to compare drainage density, and they need to indicate that at A, we have got high drainage density, at B, we have got what? Low drainage density. So even if you write only this, you get your marks, okay? So let's move on to 8 point, what call? 13. Let's look, describe 2 factors that may have resulted to drainage density at B. So we are talking about low drainage what? Density. Low drainage density. Cause. We want to know the cause of low drainage density at B, because that's all what we want here. What can result, could have resulted in the low drainage density at B? So here we can talk of what you call is gender. So gender, slope, which promote infiltration. And less runoff. Okay. Then you can also talk of high vegetation cover. High vegetation cover promoting infiltration. Then here we can also have what call, we can also talk of what call, we're done with the gender slope, and we're done with the vegetation. So you can also talk of high permeability, high porosity, and permeability of soil. Okay. Now, so it means that it's promote this, they do promote what you call infiltration. So we're just saying here, when we're talking of low drainage density, we're talking of promoting infiltration. What promote infiltration? That's what they're just asking you here. What promote infiltration? That's what we are just saying here. When you have got low drainage density, what is promoting infiltration? Now, what else can we also add there? As we know, we can also talk of high evaporation. High evaporation. And you can also talk of less precipitation. So low precipitation. We have a lot to say here. Precipitation. That also could have resulted in the low drainage density, because when you've got low in precipitation and high evaporation, it means that we don't have much runoff there. Okay. So I think I've added more here. You can also refer back to this what I call part here to understand here and read this part here. Okay. So this one here will help you very well, because when you've got we're just saying what resulted in the low drainage what you call density. Now let's move on to the next one, which is 8.14. Write a paragraph of approximately 8 lines discussing how human activities could have impacted on the drainage density at A. So what could have resulted here in the what you call drainage density at A? What did we do as humans? To cause high drainage density. Now we are just saying, what are the activities that will promote what you call a low high in precipitation? What are the activities that will promote what you call the less vegetation cover? What are the other things that will promote low high drainage density? Is first of all, what we can start with is, as humans, what do? We cut trees. So cutting down of trees. So we are saying deforestation, or we can just say cutting down of trees, vegetation cover, increasing runoff. So here we are just being asked to indicate activities that promote runoff. That's what is being asked here. Activities I just want to remove this. Okay. Activities that promote runoff. That's what we want. Okay, so let's get to it. Let's get to understand them. So here we have got activities that we have. So this one, we can just say deforestation. Then here, let's have another one. We can also talk of natural, what called overgrazing. Overgrazing. So overgrazing, when you overgraze, you've got more kettles or more kettles on a small area, and will remove the vegetation cover. So here reduces vegetation cover. Okay. Then you can also what called incorrect plowing. Plowing. When you are talking of incorrect plowing, you are plowing what called down what called the slope. So when you plow down the slope, what's going to happen is increase what called erosion that promote erosion. Okay. Then here we can also talk of what called over cultivation. or incorrect cultivation. Yeah, we can just, this one is more like the same as what you call, then also building of houses, building of houses. So building of houses, again, you are clearing what called the vegetation. When you are removing, you are increasing what called runoff. So when we're talking of these activities that promote runoff, we're just talking of how does activities, our activities affect what called vegetation, because here mainly we are focusing on the effects on activities affecting vegetation cover. So let's just indicate there that what we are just focusing more here is vegetation cover. That's the most part here. That's the most part, because other factors like rainfall, what call the porosity, that one also, overcultivation will also increase the porosity. Yeah, here overcultivation increases what call the permeability, increases permeability of soils. Okay, that's what we need to know here. Overcultivation increases, the soil becomes loose over time. So soil becomes loose over time, allowing more water to infiltrate. So it will increase more infiltration. Now, here, let's look at what is it? What is it? We're saying 8.2. The diagram below represents drainage density. Start it and answer the question that follow. A and B, define the term drainage density. We have done this one, guys. Which one of the drainage density A and B show drainage density during the dry season and rain season? So here we are saying this one here is a dry season. This one here is what called wet season. That's what we have there. So that one is answered. Explain the drainage density of the drainage, what called basin changes during the course of the year. So explain the drainage density. So we're just talking of changes. So we're just talking about what happens dry season, because course of the year we've got dry season and what? Wet season. What really happens? Okay. Okay, let's look at what happens. So let's talk of a dry season here. Now, during dry season, we have got low rainfall. Remember the factors that affect drainage density. We have got low rainfall. And when we have got low rainfall, what happens here? We have got what called a high infiltration. Because whatever that that comes, that we receive, it means that what call is going to be during the dry season. What's going to happen that we have got high temperatures, then we have got, since the soil is not saturated, so here the soil have less moisture, so that's why we've got high infiltration. Why? Because soil have less moisture. Okay, so what about the wet season? Wet season here, we are saying we have got high rainfall and we are saying there is also high runoff. High runoff because of what? Soil have as the soil are saturated, are saturated. So when they're saying they're saturated, they are full of water. So they have enough water. So they have what? They have absorbed. Saturated means that the soil is absorbed enough water. So they can no longer take more water here in the wet season. That's why we're saying it's promote what call the runoff and also promote high drainage what called density. So here what we have in the dry season, we are saying they are associated with what? Low drainage density, and here we are saying it's a high drainage density. Okay, let's move on to the last question here, 8.24. The changes in the drainage density changes the stream order of the drainage basin over the course of the year. In a paragraph of approximately 8 lines, explain why this is the this is the case. So here's the thing here. Stream order, we are saying when you have got talking of stream order here, we're talking of amount of rainfall also being received. So we are saying there are changes, changing the drainage density, changes stream order. So we're just explaining the same thing here, that during the dry season, here what do we have during dry season? We've got low rainfall, low rainfall, low rainfall, high infiltration, okay? And when we've got high infiltration, it means that we are forming less streams. So low streams, so less streams formed. Resulting in low stream order. Because remember, stream order, streams need to join. When they join together, it means that what are we going to have? We are going to have what called more streams. When you've got more streams, it's also increase what called the stream order. Now, what about the wet season? Wet season, we are saying, is high rainfall, and we've got high runoff, more streams formed, or we just say more active streams. So here, active. So we are saying more active streams resulting in what? Resulting in what called high stream order, because we have got more streams joining to each other here. Okay, guys, so here is the thing here. I hope you guys have understood the relationship, of these streams, and also change of seasons, that in the dry season, we're talking of rainfall here, because since we said drainage density is also affected by precipitation. So precipitation is a factor. How does it affect? If we've got high rainfall in the wet season, we are saying there is also high drainage density, and also we've got more high stream order. As you can see on this one here, we have got low stream order here, because we are saying there are less streams joining each other. So we see that the stream order here, if we are to check here, it's actually here. If we can say here is stream order 2, then it comes here, it's stream order 2, then here it's stream order 2, then it comes here, stream order 3, then until here is stream order 3. But if you have to check on this one here, this is stream order 2, this stream order 2, so it's stream order 3 there. And if you check here, stream order 3, then if you check here, this one, stream order 2, then it forms, this one is stream order 2, this one is stream order 3, and when it gets here, it's now stream order 4. So you can check, you can see also that by the time we reach this side here, it's stream order 4. Why? Because it's a wet season and more streams are active, and you've got more flow and what called high runoff. Okay, so until next time, guys, thank you so much. All the best.